going to understand something called what is this phenomena, hydroplaning. So hydroplaning is something complete lifting of your vehicle tire wheel interaction from the road surface is what is describing hydroplaning. So how can it be happening when you are driving? So when you are driving at higher speeds and suddenly you are braking your vehicle, what would happen is the contact surface of the tire with the road would disappear and the fluid film will occupy completely. So you could see here there are two pictures. One is by figure A, which is called partial hydroplaning. Another one is complete hydroplaning. So what is happening? You imagine that when you have a road surface with the water on the road surface. So as you drive, your vehicle tire would have a contact with the water film, and in front of the tire, the leading end of the tire tread would be having a wedge formation. So the water and this interaction would be a wedge formation. Water will be moving out at the low speeds. That's what you see here. Point B is what is breaking, right? Breakdown of water film. So that would happen at the lower speeds. But the same vehicle, when it is crossing the wet surface at the higher speeds, what would happen? You would not be able to distinguish this A, B, C clearly, and you will see suddenly the film of water comes between the tire and the road surface, and that is the scenario where you would lose the complete control of your steering on the vehicle, and the vehicle stability cannot be ensured, and you will have an unsafe situation of the vehicle. So what is that is making this complete occupation of fluid between the tire surface and the road surface? That's because of hydrodynamic force, lift force. There is a hydrodynamic force that is being generated between the tire tread as well as the road surface. And that hydrodynamic force will have two components. One is the vertical component, another one is the horizontal component. Horizontal component, we call it as a drag force component. Vertical component, we call it as a lift force component. A lift force component is very important. So that lift force, this H is hydroplaning to refer, is proportional to the area of contact of the contact patch and the density of the fluid occupying between the tire tread and the road surface. So there can be rainy season, so you go, there is water stagnant on the road surface. There can be a situation on a road surface, spillage of some lubricant from the tanker, and that lubricant can spread across the road surface, and that can be also be a fluid. So it depends upon the density of the fluid which is there on the road surface, and most importantly, it is going to be depending on the velocity of the vehicle, your wheel center of the tire wheel assembly. That's the vehicle speed as well. So if you look at it, the square of that, it's proportional to the square of it. That's why this hydroplaning phenomena is more pronounced or more visible or happening with the vehicle of higher speeds. So the high speeds, if you look at, the passenger cars are high speeds on the highways, whereas if you look at relatively, the trucks are going with the lower speeds, right? So you see the trucks are not going to have mostly this hydroplaning phenomena experiencing, whereas if you look at the passenger cars, they are going to experience that even at a nominal speed of our drive of some 80-90 kilometers per hour speed and highways, which we normally maintain. Suddenly you see the road with filled with fluid surface, and you may have such a scenario called hydroplaning. And that is going to happen whenever you are braking on surface. What will happen whenever you see there is a sudden change in the road surface? You see there is a fluid on the road surface, you tend to apply brake. When you tend to apply brake, what would happen? The phenomena is called hydroplaning phenomena. So that is all because of hydrodynamic lift force. Lift force component. So what is that will happen? This hydrodynamic lift force would balance the total weight that is acting on the tire wheel assembly, and slight increase in that would make that occupation of fluid between these two. That means there is no contact of wheel with the ground road texture, right? So that would happen. So how can this be avoided during our hydroplaning? That's what you see the tread pattern with the different patterns. Treads are with the different patterns. For example, if you look at the tire with the ribs and the tire with the ribs with the sides, that means lateral grooves and all. So the tread is not a smooth tire. Like if you look at the race car tires, maybe they are very flat, smooth tires. Whereas on the other hand, if you look at a passenger car tire, you would have the tires with the circumferential grooves, and you'll have lateral grooves. So circumferential grooves tire alone are there, that's called rib tires. And you have lateral grooves are the randomized tread pattern, they are called side to tires. So when you have such kind of tire treads, and they are facilitating to avoid this hydroplaning phenomena by means of making a ways of escaping such water film out of this interaction. So they will be guided through the channel, through the grooves of the tires, and that will go out. So when you look at, you will have water depth. So if you see, there are parameters called water depth. Number 2, you would see a parameter called, just a minute, surface texture. That's just now we have seen. These are from the road. So surface texture, we have seen 4 different surface textures that's possible. So macro, rough, and what is preferred? Macro, rough, and macro texture. So this one, macro smooth and micro rough road surface, or these type of road surface. So this road surface is common road surface. When you look at, you would see there its influence. Like we will see with the different road surface influence what will happen. And water depth is, what is the water depth from the top of the water surface to the bottom. So if it is of this type of road surface textures, it will be filled between voids of the road surface. So the voids present there also helps the water to go away from them. So these are the 2 parameters that comes from the road. And similarly, you have parameters that comes from the tire. Those are called tread pattern. So the type of tread pattern going to influence hydroplaning. And you have tread depth. Tread depth. So what do you mean by tread depth? So tread depth is something from the tread pattern to the, you can see the tire, you can see the groove depth from the outer surface of the tread. So what is the depth? That's what is tread depth. So that would be decreasing as the wear of the tread that takes place. So as the usage of your tires, you see that the tread depth is decreases. The more the tread depth, you will have more accommodating water whenever such scenarios comes. And if you have grooves, channels, more of appearing on an unweared tires would channelize them to escape. And you would see that the first scenario, partial hydroplaning may only happen, not full hydroplaning. Or full hydroplaning would happen more easily on a smooth tire or more worn out tire compared to the new tire with the tread depth. That's why you have to also frequently change as soon as there is more wear in your tires, the tires of the vehicle. And most importantly, also you should look at the tire material as well. Tire material as well. So if you look at truck tires are naturally basically made of natural rubber compounds, whereas on the other hand, passenger car tire is of the treads are made of synthetic rubber compounds. So if you look at the natural rubber compounds are more good in abrasion resistance, whereas they are not that good in hysteresis. So they will have more of rolling resistance. compared to that of the synthetic material which are used in the passenger cars. So the stopping distance on a wet surface, if you look at, generally will be more for the trucks compared to that of the passenger cars, so on and so on. So you would see the material of the tire also would have an influence on the hydroplaning. And this all on one side, ultimately you should look at the different operating condition of your vehicle. What are the different operating conditions that you have seen? It can be a free rolling condition of the vehicle, or it can be of either traction or braking alone, or it can be of cornering, or it is combination of cornering and braking. So these are all various operating condition of your vehicle. These all are going to constitute an influence on your hydroplaning phenomena or the behavior of your tires for wet surfaces. So, so you understand what is hydroplaning. Hydroplaning is separation of tire surface from the ground because of film of fluid that is occupying, and this entire occupation or separation is because of hydrodynamic lift force component, which is basically proportional to the area of contact surface and the density of the fluid and the velocity square of the vehicle. So when this lift force is equal to that of the weight of the tire wheel assembly, that weight, that load that comes on this, and that is the complete hydroplaning that takes place. And this would be normally happening when you brake on with the high speeds, because high speeds means you see the hydrodynamic lift force is increases. At low speeds, you would have relatively this value is less, and that would lead to partial hydroplaning. But even partial hydroplaning to be avoided. Why? Because if this is happening, it is going to reduce the tractive performance of your vehicle. So if I have a lesser contact surface, like only C zone of the contact patch, already we have seen we'll have to have an adhesion zone, sliding zone, and so on. So if your contact patch length from LT it reduces to only this much length, you will have your generation of the traction here is so much further limited. So it is going to reduce the tractive performance, and this will be more pronounced on the truck tires. So truck tires traction as reduces, you would see there will be more consumption of fuel. So whatever may be the fuel you burn in the plant, and then it is giving you the driving torque. But unless and until you are having necessary contact length of your tire, you would see always the traction that is developed is dictated by the road surface coefficient mu as well as on the load. So when I say road surface coefficient mu, so this hydroplaning phenomena is going to affect on the values of mu on different load conditions and so on. So that is what we see here. So here mu is 0 and here there is less mu. So if it is complete contact there, then you will have more mu. So dry surface you look at, mu is different. Wet surface you look at, the road coefficient is different. So hydroplaning would reduce the mu value. In turn, it would take more of your fuel, and that would reduce the tractive performance. So what you expect. So this is all what in general we should be talking on this hydroplaning. So how do you quantify this hydroplaning speed? So if I drive with the vehicle, passenger car I choose, so I know what are my inflation pressure of the tire. So how do I calculate my hydroplaning speed? At what speed I will have this separation? The complete hydroplaning would take place. That is going to be very dangerous to my vehicle. If I know that speed, I can always be alerted not to drive at that speed. So how do you estimate that hydroplaning speed? So that's what is proposed by two scientists named by Hahn and Joyner. They worked on, they are from NASA, they worked on more on aircraft tires when they are landing on a wet surface, what are the hydrodynamic force that's developed, and how do you quantify hydroplaning phenomena, because that is going out of the runway, what would happen. So there's a lot of research they had made, and they propose some empirical formula based on that following, like this hydroplaning speed is basically depends upon the inflation pressure of your tire. How? Because that can be understood easily, because it is directly proportional to the normal ground contact pressure. Nominal ground contact pressure, how do you get the load on the vehicle by the area of contact? That's what is nominal ground contact pressure, and which is in turn is proportional to your inflation pressure of the tire. So they had proposed the formulas. Vp is given by 10.35 within square radical square root of pi in kilometers, miles per hour. This is miles per hour, first one, or it is 6.34 under root of inflation pressure kilometers per hour. So 6.39 psi is what is going to be 1 psi is equal to 1 psi, 1 pounds per inch square. 1 pounds per square inch is what is equal to 6.39 kilopascal in SI units. So we know normally a passenger car inflation pressure varies from 30 to 35 or 36 psi. So the corresponding pressure would be around some 250 kilopascal, say 250 kilopascal. So if I put 250 kilopascal here in this formula, I would have my hydroplaning speed happens to be around some 100 and 100 something. So if you substitute that, you would have the value. So what is that value? Just substitute and find out. I do not have a calculator at the moment. So it would be around some 100, approximately equal to some 110 kilometers per hour. So if I take supposing of lower range of vehicle inflation pressure, say 28 psi, so it would be around some 88 kilometers per hour. 28 psi, I would have 88 kilometers per hour. So these speeds are normally the driven speeds of the passenger car on highways. So you would see the vehicle control system is very much essential. In such scenarios, the vehicle has to reduce the speed just before it is going to undertake this course in advance, so that you would avoid such kind of unstable state of your vehicle, where you would lose complete steering control. Correct. So these are all something that you should have to understand. On the other hand, if you look at heavy trucks, the normal inflation pressure of the tire varies from 90 to 120 psi. So if I substitute that in the first formula, I would see that the hydroplaning speed comes around 160 kilometers per hour. So it is definitely not recommended, not been seen on highways. The trucks are driven at 160 kilometers per hour. So if it goes, then only you will have this hydroplaning problem for your truck tires. And that also, that length of your fluids are completely on the length of your vehicle, more than the length of the vehicle, then all tires may have that problem, and then you will lose the control. But however, what is important for the point of view of heavy trucks, heavy vehicles on the road, is that would eat away your traction performance. That's what we were discussing some time back. So that is the reason why you would have the tires to be properly designed. The road pavement should be properly made in order to meet whenever such scenarios are there. The separation is prevented even at high speeds of your vehicle. The lift force would not be balancing the normal weight, and the contact is ensured, provided these all aspects are made. So you would have water depth is not much, because your road surface is porous, it has been taking inside, and then surface texture is such that the surface texture is such that you would have smooth macro structure and rough micro texture. What is the advantage of smooth macro texture? Smooth macro texture would have more channel to flow the fluid. Rough micro texture would have more protrusion. So if water depth is very less, and then tire contact would be ensured. So as the tire goes over the such road, the water will be pushed down, and then because of smooth macro texture, and because of rough micro texture, there is a protrusion, sharp peaks of your aggregates that would pinch on the tire surface, so it will avoid this phenomena. So that is what is that you have to understand. So read the textbook; it is very interesting, like story reading. You'll have every statement points are logically placed, the evidence of different experiments conducted on the vehicle, and the results are discussed. So you would get a wholesome of this topic what we are discussing. So now with this, let's just go forward to look at some of the case studies that are presented to understand this tread design. The tread design is what we have now just now looked at, right? Tread design. So tread design means what are the different types of tread profiles. So here SM means smooth tread profile is one, and ribbed surface, circumferentially made a groove, and ribbed with sides. That means that you'll also have some lateral grooves. So if you have, these are the three different types of treads, tires mounted vehicle, their influence, their effect on the road adhesion coefficient μp on a wet surface is carried out, and that is reproduced by SM Clark. So you have a handbook by them. So you have a lot of data, experimental data. So in this you see, I have these four graphs to observe. On vertical axis you see μp, which is the characteristic of the road surface, road adhesion coefficient. μp times load is what is deciding our traction. So you would always have this fx is limited by less than or equal to μp times w, always that we know, right? It cannot be more than this. It can be equal to this, that's the maximum possible, and it cannot be more than that. So this is an important understanding. So if it is pure traction, this; if it is braking, only this is. So you will not have traction braking simultaneously. Cornering, maximum cornering force is limited by this. Cornering come braking, you would have both are limited. The resultant of both are limited by this. This all we have already seen. So for a given load, if you look at the tread design, how does it going to make an influence on a wet surface, the μp value on a different road surface. So you have this quartzite road, and you have asphalt road, you have a gravel road, you have a concrete road. So these all four cases may be accommodating the four description of the road texture that you have seen on the first slide. Now you see what is that you have to observe here is smooth tire you take it. Smooth tire compared to that of the siped or ribbed tire on an asphalt road has got a pronounced influence as a function of speed. So when I increase the vehicle speed, the smooth tire on a wet surface would lose its μp value so quickly compared to the other two. So you would see the design aspect of ribs or sides with the ribs are more required on an asphalt road of the road vehicle tires. That's why you see always the passenger car tires with the tread patterns, with more circumferential and lateral grooves, and that would have less reduction in μp compared to that of smooth tire. So if you have only smooth tire like a race car tire and you go on a asphalt road surface, that's not suitable. You don't see the vehicle with this type of smooth tires on the roads. So this is that important point that you have to look at it. And the same you would see the case of concrete road as well. Whereas it is not the case with the quartzite or gravel roads, as these road surface texture and the are different. It's macro texture and micro texture are the aggregates in this type of road surface or gravel. If you take their road textures are different. So the influence of the tread design is not much pronounced on these two different road surfaces. But when you look at the road vehicles, these are the two roads that you would commonly encounter for the road vehicles. So this is what is some of the results that comes. It shows that influence of speed and design of tread for your width surface characteristics. So Meepy Valley Falls. So you know Meepy Valley Falls. Also you have that another important thing is the coefficient of static coefficient of friction. So that is the scenario where 100% spin or 100% skid that you have witnessed in our yearly study. So that's what here is again looked at it. So in case your slip value goes beyond the maximum slip value and it's going to be 100% spin, what would happen? You would your entire interaction would be mu s times w. So again the same scenario, you could see these differences here, right? Whereas for this value is almost there's no much deviation. So this is what is our more focused practical scenario of our road vehicles, and smooth tires are not preferred on the road vehicles because that is not good for to encounter hydroplaning. So this is one aspect to look at tire design, different road texture as function of speeds, and to interpret these graphs. These graphs to interpret, we have looked at what would happen to the mu value as well as mu value. So that is how you should read. And these are the data taken from this National Bureau of Standard, in very early standard, edited, composed by S.M. Clark. He is very well-renowned person in this field. Again, you look at here design of tread design and the surface condition on the degradation of cornering capability. We looked at earlier MUP in general, and cornering capability. If you look at, I do cornering, what would happen to me? So cornering on the side force, that is cornering force on wet surface as well as dry surface ratio is taken as a scale to look at it. If this ratio is 100%, means what? Whether it is wet surface or the dry surface, I would have the same value of lateral force. That's the meaning of this ratio is 100%. This ratio is of 0%, means what? What is that is possible on a dry surface is not possible on a wet surface. That's the meaning. And in this graph, we are able to look at, for example, see here, it is the point or this is the speed corresponding to hydroplaning speed. And what are these curves? See, you have one solid line on dashed lines. So solid line is for textured concrete, and another one is smooth concrete. So it is for the concrete surface alone for different tread design. So here you have 4 groove tread. Water depth is given 1.02 mm. Look at water depth is 1.02 mm. We will not feel that actually water layers. It is just one wet surface only we will see. So this so small depth on this water film on the road surface, naked eye we could not make it out. There is stagnant water. If this is that water surface and you have 4 grooves on the tread, what is happening as increment of speed? So you see, as the speed increases 20, 40 miles per hour or 50 kilometers per 100 kilometers per hour, see it is so much fallen down here. So in case of textured concrete, if you look at, that means you would have textured concrete will have micro roughness nature, whereas smooth concrete means you will not have even micro roughness. So the hold of your road on the tire is so less. So you see that difference of the road texture. So one that could gradually reduces this or suddenly drops in case of smooth concrete surface. So these are all other studies that people do. So like that, one can do a parametric study to understand the significance of your road surface nature and your tire design and tire material properties for different operating condition of your vehicle, right? Here, this is again a comparison of peak value of road adhesion coefficient and the sliding value of road adhesion coefficient for a car and truck tires on wet surface. So if you look at always for this one, A is for car tires, I suppose. Yeah, car tires. B is for truck tires. So the standard region by A, if you look at tread depth, here what is tread depth is one of the design aspect. So the tread depth will be decreasing as the usage of your tire. As the wear of the tire takes place, the depth will be decreasing. That is the depth of the groove from the outer surface. You can say tread depth. So if we have tread depth of 7 mm, tread depth is 0, what is happening? So tread depth of 7 mm is the new tire. See, MIP is not at all, more variation is very less. As the prolonged usage, the tread depth is decreases, you see the drop in MIP for the car tires. The same thing happening with the truck tires. But when you compare the car tire and truck tires, you see that the MIP value is so its variation is here. Maybe in this low speeds, you see it's pronounced more compared to that of as the speed increases. But however, the performance of tires on the car is better than the truck, right? So this is what is the influence of tread depth. Tread depth. And what is here is just you have like you looked at earlier in the slides for MIP as well as MIS. We are looking at here again variation of road elevation MIP in this first plot and MIS on this plot. And for the variation of tread depth of car tires as well as of the truck tires, right? So this again brings in this kind of observation of results brings in this picture easily makes no to remember this variations in our mind. And these are all something that I would like to talk on tire performance on wet surfaces.